Assalamualaikum viewers. Today we talk about quicksort algorithm analysis. Today our topic is this. So in this topic we will study its algorithm and the best case, worst case and average case scenarios about the quicksort and its comparison with other other sorting techniques like insertion sort, bubble sort and mud sort, etc. So basic on introduction, we see here that the sometimes the quicksort is also called partition sort, partition exchange sort. So the quicksort algorithm was developed in 1959 by Tony Hoare while in Soviet Union as visiting Moscow State Student University. The quicksort algorithm uses the same idea as the merge sort algorithm, but as a divide and conquer technique. It divides an array into the subparts and conquers and sorts the array using the merge sort technique, idea of the merge sort technique. So as we see here that the recursive functions, the quicksort uses recursive approach. As the quicksort uses recursive approach, so it is very efficient and cache efficient. So it does not load fully cache and RAM, main memory of the computer, as it stores its value temporarily in cache memory. So because it is using recursive approach, so it is very easy for the quicksort to get well managed with the sorting arrays. So it's very fast also, that's why. So it picks an element. The technique of quicksort is it picks an element as a pivot. It selects an element from array as a pivot, and by using it, it partitions the other array and sort it ascending or descendingly. So moving on to the pivot, let's see what is pivot. So pivot. So pivot here is the so it is the therefore pivot. So there are many types and version of quicksort to pick as pivot. So pivot can be select randomly from an array, whether it is first element or the last element. It is picked randomly from the element, as we see that if and this is an array with 5 elements, suppose 1, 2, 3, 4 and 5. So our decision is to pick any one pivot from it. We can choose as 1, 2, 3, 4, 5 any pivots from it. So it's work on this scenario. So here we see on move on the next slide for your approach, easy approach. Sorry. Here, randomized quicksort. Randomized quicksort is the to choose the pivot. It's a basic of concept of choosing a pivot randomly in an array. Randomly, as we see here, we select first or last element as a pivot in partition method. Always like in certain conditions, 80 to 85%, we choose first or last element for partition as pivot in quicksort. But here to introduce randomization, it is the algorithm is picked random, as the pivot is picked random, sorry, according to the input sequence of whether it is last or first. So here we see that the selected pivot will always divide a sequence in a reasonably balanced manner. So if the one element is selected as pivot, it will divide an array into sub-arrays like this. So it is 1, it is 2, it is 3, it is 4 and 5. So one is selected as a pivot, so we can see it will divide it into all. So the variation of this variation is also called randomized quicksort, as we have mentioned earlier above. So it is a good technique. Randomization quicksort will give, it's an basically an average case scenario, so it will give n log n time complexity, so which is the best time complexity also of the quicksort. So here we see that the quicksort will, how to manage its work, how quicksort manages its work. The key to quicksort is basically the partition method. The partition method selects a pivot from an array and divide into several sub-arrays and then sort it, as it uses divide and conquer approach. So if it is selected as a pivot, so it will use partition method to be selected as an pivot, so it is selected as a pivot. So if we see the target element partitions of an element x and array as a pivot, put x into the correct position. As these all lines says to how to choose, we choose the pivot from the array. So all this should be done in linear time. It is done should be in linear time because we have sometimes issue of unsorted sorted array also. So it should be if there is sorted like this 1 2 3 4 5 6, this array is sorted, so it will do time complexity greater. So it reasonably moves in a balanced manner. So if we see the quicksort working of a quicksort here in this example, see the the pivot is chosen as 70, the first element here we see. Then it is divided into sub arrays, the which value is n by 2 and n by 2, as we will see in the next best case scenario also. These values deviate, and then 50 is chosen as a pivot from this sub array and divided into this, and 40 is also chosen as the limit for the this array and divided into sub arrays, and therefore the last element remain, and also from this sub array 80 is chosen as pivot and 90 will remain in the sub array. Then we sort it from last to the first to get a sorted array which valued correctly. So here we can do that. Then we see the working analysis of the quicksort is, see the one element is chosen as pivot, as I have mentioned in this example above in this example. So it is basically working on that. If the element is chosen as pivot, it will move to the centralized position and divided other arrays into sub arrays and unsorted partition. Then the partition method is again called to sort the whole array, and the array will be sorted and get into the this position. So then the array will be sorted according to us, according to the quicksort method. So as we see the quicksort function, it is the sorting function technique used is the main program to sort it. As according to the partition method, we pass it array size, low and high values assigned to the an array given by us. If then we check the condition. If the high value is greater than the low, then it will comes into it and assigns a partition method to it, which gives it the path towards the partition method, and this will then go to the partition method for the working of a whole system. And as we mentioned earlier, this partition method will choose uh, the pivot, first of all the pivot from it, and see the if the array is low, if the low value is -1 is assigned to the I incremented pivot is assigned as the array of value high. If the array has a high value, it is assigned to the pivot uh, array of high assigned, which we have assigned to the pivot. And this function works same like method and goes incrementing on that. And if the function running is completed, it will again go towards the sorting function of the sorting function of the quicksort array, and then it will comes towards the quicksort array. And according to the recursion, it uses recursive approach, and again uses it as a recursive approach. So it will come here again and again call the partition function. So if we see again it will call again the partition function, and uses the technique to divide and the pivot around sub arrays, as we have seen here. As the pivot is divided into two sub arrays, pivot is not, the array is divided into two sub arrays, and which are unsorted. And according to the third condition of the quicksort, it will this condition will solve the left arrays according to this, the left array, and the other will sort the lower will sort the right array. So here we see all the algorithm analysis to do quicksort algorithm analysis. It is the quicksort analysis has different case scenarios, as I have mentioned earlier: the best case scenario, the worst case scenario, and the average case scenarios. It will greatly depend how the quicksort algorithm works. We have always to use best case scenario for the efficient working of the quicksort algorithm. So we always uses the quicksort because the best case scenario has big O n log n time complexity, because it's efficient and it works properly according to that. So now we discuss the worst case scenario. So the worst case scenario occurs if the process partition always picks the greatest or smallest element as a pivot. If we select an element from the array which is greater or smaller in array, so as 1 if is selected, and 2, 3, 4. So if we select this as pivot P, or this as pivot P, it will not satisfy the condition to use a pivot which is equal to median. The pivot always have greater value on the right side, and the left side has the smaller values according to the pivot, and the pivot is centralized and divided into sub arrays. So this will not satisfy that condition. So this now we see the worst case scenario. We are seeing the worst case scenario. As the pivot is divided into other arrays, it will have the same value, and this will have to increase the time complexity. As the array is solved in the quick sort, as we have seen earlier, if the array has 1 2 3 value, 1, okay, 1 2 3 value, the array is sorted, but it have chosen as for example the one has chosen as pivot P. So in the next step it will run, it is sorted, then it will choose the in the next step the pivot P2. and so on. The last element of pivot will be p3. So it is sorted, we have seen, but it will run, and the time complexity increases because the program checks and runs whether the time complexity increases or not. This will increase the time complexity. Then will occur in the worst case scenario, as c n times it will run, and then n minus 1 times, as the 2 is chosen, then 1, uh, then 2 will remain here, the 2 will chosen as a pivot, and 3 will remain. 1 was chosen first as a pivot in the as I mentioned earlier. Then this time complexity becomes n minus 1, and the further when 3 remains, the time complexity will remain will become n minus 3, and so on, as we see here. So moving on to the scenarios, we have seen here that how it works according to that. As we see here that the time complexity of area of size n, how to find the time complexity of area of size n, t of n, to find the complexity, worst case complexity, time complexity of an array, sorted array. So here we have to add the n numbers of the divided partition, which has done in this method, as we have discussed earlier. In this, the n number of elements, the size of the element of an array, so it will run n times also. This is a common sense question, and now we see, then it is divided into sub arrays, and one element each time is chooses as the pivot. So it will time complexity become n minus 1 for the one array, as I have mentioned earlier, and the time complexity of work done by the quicksort of array is 0, because the pivot has done nothing. Pivot is selected and compared, but the pivot has the value nothing, because it's an in an sorted array. So if the pivot is chosen 1, so it will do nothing but a comparison, so because it is present in the sorted array. Now if we see the time complexity here, so we will do the running time complexity of the partition of array of n minus n elements, n minus 1. The subarray is divided as 1 was first chosen the pivot, then 2 was chosen the pivot. So it works on that process. The then plus copying and pivot, the n pivot, as we choose the first element as one pivot, and this equal to n. This will process all equal to n, because it will runs n times of an array. So solving this technique, we will see that time complexity of the first partition is t n minus 1 plus n, and the second partition will be t n minus 2 plus n minus 1 plus n, and the third partition goes on increasing, the values adding. As we see here, the value is decreasing, and incrementally if we move on the right side, the value is adding and decreasing here. So in the for the third time, it will become tn minus 1 3 plus 3n minus 1 2 n minus 2 plus t into n minus 1 plus n is the total size of the array, and the running time complexity, the array checks according to it. Now it will continue so on until we develop a common technique and understand their working, and developed a series that t of 1, it is incrementing. See, all the elements are incrementing. As we see here, the 1 is adding to the minus 3, and it will become minus 2, and here the 2 is adding, and so on. Here we see the time complexity is increasing by one each time. So it will starts from 1 and goes to the n minus 1 till the last element comes and adds into the one element. So here we see the it is adding to the n elements, and we see the n number of elements is adding, and their time complexity will be n into n plus 1 divided by 2 plus this element n. Now if we multiply this n into the bracket function, then we will see it will become n square plus n over 2 plus n. As we see here, the dominant value is n square, so it will be the running time complexity of the worst case n square, big O of n square. So hence we have reached the solution that the time complexity of the worst case scenario is big O of n square. So move on to the next scenario, that will be best case scenario. Here in best case scenario we see that the partition process will occur if the we picks the middle element as a pivot. If the middle element from an array is selected as pivot point P, it will divide other sub-arrays into n by 2 and n by 2 equally partitioned sub-arrays. So its time complexity will be omega n log n, or big N log n. Is the best time complexity to solve an unsorted array and can become it a sorted array, as it is also called best case scenario, as we have seen here. So we will see now an example of that scenario, best case scenario. Now in the best case scenario we will see, as I have mentioned earlier, the pivot is chosen and the array will be divided into two sub-arrays. The left array will contain the elements lesser than the pivot, and the right array will contain the elements greater than the pivot. Now it will uses the same scenario as n by 2 divided into n by 4, n by 4, and so on. It will continue as it is divided into sub-arrays and so on. So here we see the time complexity, and now understand the time complexity of the best case scenario in the quicksort. Now we will see how it's done and how its working will be done, how we prove time complexity and log n. The array time complexity of array n of size n, t of n. If we have to find t of n, we will add the time complexity of the sub-partition arrays, which will be Tn by 2 plus Tn by 2 of two sub-arrays which have time complexity n by 2, and the partition n, which is the total time calculated of array of size n. We will see now here how it works. So now we have seen that this partition will add up and it will become the 2 multiplied by Tn by 2 plus n, total number n. This will become the time T of n, and now we have seen that if we put n here is equal to n by 2, then we will see that the n by 2 will become n by 4, as we 2 is multiplied by 2, then this will become n by 2 and n by 2. Now here, the value of this n by 2 we put in equation this to sort an array, and now to sort the time complexity of an array. Now it will become a 2 of this array, and the t of n value is given this, as this is the t of n value plus n. And now if we multiply in this subarray the sub partitions in the brackets, then it will become, the time complexity will become this, as 2 is cancelled by this 2, and it will become n, and this will remain the same, as it will become 4. And we see here the value of 2 is increasing step by step. 2, then 2 power square, which is equal to 4, then 2 power square cube, which is equal to 8, and then it will increase gradually as we go beyond that. And we will see it is working same as so on. So the time complexity here, which the value is incrementing, these values are incrementing. So here we use the sorting analysis and the theorems of this series. This will become 2 power k times, it will use up to k times, as it is increasing 1 2 3, so it will go up to n times, multiplied by t n by 2 k times. The power of the inner array of the inner sub arrays will increase also n times, as it is equal to k. So here the time complexity will be calculated as we have seen this is a constant value, so we can exclude it because it's not important, so that important because it's a constant value, and the remaining value will be 2 power k plus k multiplied by n. Then we have to find the value of k. What is the value of k? K have the value log n. Okay, if we see that the k have the value log n, log n, then we have to put the value of the log n. This 2k will become here, 2k will become just n, because this will log base 2 is equal to 1 all the time. Log base 2 equal to 1. So here we see that it will remain n, and this k value will become log n into n. This will become n log n plus n. The dominant value is n log n, so it will be the chosen as the time complexity of the best case scenario. So we will according to the mathematics rule, so the best case scenario have the time complexity n log n. As we have mentioned earlier, that the time complexity of average case scenario will also be n log n, because we have to choose pivot in that condition randomizedly, so the time complexity will be n log n in the average case scenario also. So we have seen that the time complexity of average case scenario is also big n log n, big of n log n. So as we here see the comparison of the quicksort versus other arrays, it will be the splitting of arrays as divide and conquer technique as the merge sort uses, and the time complexity of the worst case will be n square in the quicksort method, and n log n in the merge sort. It will work on smaller array efficiently, as quicksort works on smaller array efficiently, and merge sort will efficiently work on a size of any array. As from this we know the speed of the small data will be fast in the quicksort, and the merge sort speed will be consistent on any size of array. As it is cache efficient, it will get less space in memory, and it will merge sort will get more space in memory. Thank you.